Hello, this is the video for the special topic on data analytics, and we are still learning about recommender system. In this section, we are going to learn about collaborative filtering, section 2. So we already learned collaborative filtering, the pure CF approach, and we learned about the user-based nearest neighbor. We learn about the person correlation. We learn about the item-based nearest neighbor. We use the cosine similarity, and we also learn how to handle with the data sparsity. And in this section, we are going to learn more how to handle with more advanced methods, for example, with the data mining methods, or with some other kind of approaches like association rules, slope one, RF rec, and etc. At first, I would like to explain the two kind of approaches, which are memory-based approach and model-based approach. The one that you already learned before, it is related to the user-based CF. So CF is the collaborative filtering, and it is said to be memory-based. What is memory-based? So we call this is memory-based because we use the rating matrix. Yeah. So the rating matrix is directly used to find neighbors or to make predictions. And this memory base does not scale for most real-world scenarios. Oh, why? Okay. So yeah, even though this is good, but it does not scale for real-world scenarios because in many kind of websites like the e-commerce website, they have tens of millions of customers. So there are so many customers, and also there are so many items. So it is not, it does not scale well, because if you already learn with the 5 items and 5 customer, then it is still okay. But when it is already, if the customers have millions and the item millions items, then it is very complicated, and usually you cannot give the good recommendation. You cannot give a good recommendation. So the one that we learned before, it was about the memory-based techniques, and it relies on the similarity measures. You learn about the cosine similarity. We learn about the person correlation. We can also use the Jakob coefficient and etc. Okay. So it is to match the similar people all items. Now the issue is if we have a huge matrix. So if we have a huge matrix, let's say users on one dimension and items on the other. So we know that we have the matrix like this one. This is the user and these are the items. So the cells containing food or likes. So how many foods? For example, the user one and item one, okay, whether the person like or not, or how many stars, how many foods, and etc. So the memory-based techniques use the similarity measures. Okay, we will check the similarity between two vectors, between the row or the column, okay, to generate number representing similarity. Okay, and we use that similarity to look at the nearest neighbor. There is another approach, we call it a model-based approach. So the model-based approach, we apply in the item. What does it mean by the item? You already learned about item-based collaborative filtering. So it is based on an offline pre-processing. it means we already know some kind of model. So we already have the model, and we use this model to predict something. So at runtime, only the learned model is used to make prediction. So if you learn about the machine learning, so the machine learning, we always create a model. Maybe the model is decision tree, okay, or the model is linear regression, logistic regression. So we can use this model to make prediction. And the models are updated or retrained periodically. There are lots of variety of techniques used, and model building and updating can be computational expensive, okay? Because if there are so many items, of course, it is so complex. And the item-based CF is an example of model-based approaches. So when you learn about the item-based collaborative filtering at the previous section, yeah, it is one example of the model-based approaches. And there are so many other techniques, yeah, some popular model-based techniques, for example, Bayesian networks. We can use SVD, singular value decomposition, or we can use the probabilistic latent semantic analysis. We can say it is probabilistic latent semantic indexing. So those are the popular techniques, and we're going to learn about one of them. This is a singular value decomposition. So in summary, the collaborative filtering, it has two approaches. The first approach is memory-based. So the memory-based means we want to find the similar users, either based on the cosine similarity or person correlation, and take weighted average of rating. The advantage is easy creation and the explainability. But the disadvantage, the performance reduces when the data is sparse. Okay? Sparse, it means there are so many zero. So the performance will be decreasing. And we can say it is non-scalable. If we have a lot of users, if we have a lot of items, then it is not scalable. In the model-based approach, we will use the machine learning to find the user's rating of unrated items. So there are many approaches, for example, the PCA, SVD, the neural networks, neural nets, or the matrix factorization. So the advantage is we can reduce the dimension. Okay? So the dimensional reduction deals with the missing or the sparse data. So when we have a lot of sparse data, we can reduce it and we can deal with it one. But the disadvantage is the inference is intractable because of hidden or latent factors. So intractable, so it means it is difficult to interpret. It is difficult to interpret because it is latent factor or hidden factor. We do not know what does it mean by the numbers. Okay, so let's see with the example. So now we are going to learn about the model-based approach. More model-based approach such as like matrix factorization. Okay, so the matrix factorization is a technique based on the statistical tools, and there are some ways like the SVD, singular value decomposition, principal component analysis. We can also use the association rule mining. So we learned about this association rule mining before, or we can use the probabilistic models. Maybe we can use the clustering. We can use the Bayesian networks. We can use the probabilistic latent semantic analysis and other machine learning approaches. Yeah, so we will learn some of the machine learning approaches later. How about the cost of pre-processing? Yeah, the pre-processing will cost some time. Okay? Of course, it depends on the number of data, how about your memory, and etc. And usually it's not discussed. So we assume that the data already available and we can just use it. And is there any possibility to update incrementally? So we want to update continuously, because we know that the data might be updated, and yeah, the model, the last month model, maybe we cannot use it for the next month prediction, because yeah, it is already not up to date. So we need to learn based on yesterday model. Then we need to update it. How we can update it? So that's also another issue when we deal with the model-based approach. Anyway, we will learn about the matrix factorization. So what is matrix factorization? It is based on latent factors. Okay. So let's say we have two columns in the user matrix and two rows in the item matrix. Okay. So in this case, I have two columns in the user matrix and I have two rows in the item matrix. So this is the item, and then this is the user. Okay. So an indication of hidden characteristics about the user or the items. So let's say this user in this particular item, he or she gave the rating 4. Okay. After we know that the user gave rating 4, we want to use this metric and we want to reduce it into two different metrics. Okay. So two different metrics means we have this matrix and we have this matrix. So the one on the left is the user matrix with M users. So this is the M users. And we want to create column, and yeah, usually we can say, let's say in this example we have two columns. So the total will be M is the number of users and two columns. Okay. And the one on the top is the item with n items. So we have n items and there are two rows. So the matrix will be, somehow we can say M multiplied by 2. And in this case, the matrix is 2 multiplied by n. Then if we multiply those two matrices, M multiplied by 2 multiply with the matrix M with 2 multiplied by n, then the result will be, we have a new matrix which is the size as M multiplied by n. Okay. Now the rating 4 is reduced or factorized. So we call it factorized because we have the 4 with some linear modeling. We will have the user factor is 2 minus 1 and the item factor is 2.5, 1. Now let's look at the matrix factorization. We call this is the possible interpretation of this factorization could be like this one. Assume that in the user vector u comma v, so this one is u, and then u and v. U represents how much a user likes the horror genre, and v represent how much they like the romance genre. Okay. So we have the first row is horror movie, and the second row is romance. Yes. So if we have two rows in this case, and if we have the M multiplied by two rows, so we can assume that this is like the number of the rows in the item. So the item means, like, let's say the movie. Okay, in this movie, we can distinguish with the genre. Okay. So the 2 minus 1 represent that a user who like the horror movie and rates them positively, and dislike movie that have romance and rate them negatively. So 2 means it is positive, so it gives the horror movie positive, and -1 it gives the romance negative. So it is also the same with the item. When we have the item factor ij, so it means I represent how much a movie belongs to horror genre, and j represent how much movie belongs to romance. So let's say this one, yeah, how much it belongs to horror and how much it belongs to romance. So the 2.5,1 means that the horror rating is 2.5 and the romance rating is 1. And when you multiply 2 multiplied by 2.5 plus -1 multiplied by 1, then you will get 4. Okay? So you will get 4. So the movie belongs to horror genre and the user can have rated 5. But the slight inclusion of romance caused the final rating drop to 4. So because of the horror, okay, because the horror, there is a genre horror, okay, we can say this one, the result is 5. But because in this movie, we still have another genre, which is romance. Then because of this minus, the rating becomes 4. Okay. That's the possible interpretation, but it is not always like that one. So it will be very difficult, and it is very diverse to look at the data. So the SVD theorem states that a given matrix can be decomposed into 3, okay? U, sigma, and V transpose. So U and V are left and right singular factors, and the values of the diagonal, okay, the sigma, are called, we call it the singular values. So this is from the algebra, linear algebra. Okay, if you learn about the linear algebra, you can get this idea. We can approximate the full matrix by observing only the most important feature, which is the largest singular values. So in the example, we will use the U to represent the user, we will use the V to represent the items, and we will use the sigma to represent the singular values. And we will retain 2 most important features by taking only the first 2 columns of U and VT. Okay, so let's see with example. Now I have this matrix. Okay. Because I have this matrix, there is a question how to rate this item 5 for Alice, because it is still unknown. Because we are going to predict this one, then let's remove Alice. Okay, it is to make it easy, and we are going to focus on this one. Okay, so we are going to focus on this one, and we can make this matrix with transpose. Okay, so you can see user 1, user 2, user 3, user 4. Now the item 1, okay, so it is 3, 4, 3, 1. Oh, sorry, maybe I need to revise this one. Okay, so now it becomes item 1, item 2, item 3, item 4, and okay. So this one is item 2 is 6. Okay, so let's follow this one. Okay, so I think I need to revise this. So with the matrix factorization, okay, like this one, well, we have 4 multiplied by 4, which is 4 multiplied by 4. And the main point of this decomposition is that we can approximate the full matrix by observing only the most important features, which is the largest singular values. This is a matrix. You can just use the online calculator, or you can just use with some tools, okay? Because it is not easy to do this calculation by hand. So you can get the U, the projection of U, and you can get the V, okay? So later we will transpose it. So T means the transpose, and we can get the singular values. And this singular values, it is only for 2. If you calculate with the original matrix, so you can get the singular values with 4 items. Okay, so we can get it with 4 items, but let's reduce this one into 2. Okay, so we just use only the largest 2. So usually we use this one to make the dimension more compact. So we call this is the dimensionality reduction. And we want to find out where is the Alice data point. So the Alice data point means we know that the Alice rating is 5, 3, 4, and 4. It is for item 1, item 2, item 3, and item 4. So we can just do with the matrix. Okay? We know that when we have the matrix, it is the U and the sigma and the V transpose. Okay? And given the matrix, okay, so we can convert this one. We have the Alice 2D. Okay, so we want to know the 2-dimensional value of Alice given by the Alice. So we have this matrix. Okay, and user, we have this matrix, and we have the singular values. Okay, but in order to know this rating of the item of Alice, or we call it, this is the 2-column singular value matrix, we can do with the inverse. Okay? So the sigma, or the singular value, should be inverse, and this is the inverse result. So we have the 0.081 and 0.2 something something, and we can apply this formula. So the formula will be the matrix multiplication. We have the rating from Alice 5344, and we use the U from this U obtained by the matrix factorization and multiply with the singular value matrix for 2 column only. And after you get this calculation, the result is this one, 0.64, 0.3. Now, you can do with the other item. You can also do with users. And this is the plot for 2 dimension. If you look at this one, so Alice, the value is minus 0.64 and 0.3. Okay. So minus 0.64 here and 0.3. So here. Then this is the position of Alice. We can rely to the cosine similarity to determine the user similarity, which is the user 1 and user 2 can be the best predictor for Alice in this example. So yeah, we can apply another way. So I know that this is the position of Alice, and looking at the distance, okay, user 1 is the most similar, and user 2 is the other users who are closer to Alice compared to user 3 and compared to user 4. Okay, so we can just say that user 1 and user 2 will be the best users to predict what is the Alice rating. So again, different weighting schemes, similarity threshold, and strategy for filling missing items based on the product average can be used to fine-tune the prediction. So using this kind of SVD, yeah, we can do with another approach. For example, if I know the location, I can select the users. If I know about the item ratings, I can select also the closest item, right? The closest item, and yeah, I can use the item-based collaborative filtering to do the prediction. So this approach, we call it, this is the SVD, or the singular value decomposition based recommendation. Now I have a question. Okay, suppose below is a rating of pop on item 1 until item 4. So using the matrix given in the page, the previous page 15, can you find the data point and figure out 2 nearest neighbor users? So you can use this one. Okay, so using this U, you can use the V, and you can use the sigma. Okay, you can use also the inverse of the 2-column singular matrix. Okay, this is the inverse of the 2-column singular matrix. Try to figure out what is the point. Okay, so this is the point of Alice. Now, can you figure out the point of Bob? What is the point of Bob? And figure out the 2 nearest neighbor users of Bob. So feel free to use online calculator or calculator with matrix multiplication tool for practice. Okay, so I will stop here and we will see you in the class. Thank you.